So today we'll look at matrices. It's a very simple concept here. Right, that day we did we talked about the orders of matrices because we could call a matrix a 2 by 2. That 2 by 2 meant the order. We could call a matrix 3 by 2. That was the order. When you say order of a matrix, you mean the number of rows cross the number of columns. So it's row by column. So basic information that we need. The basic information. If A and B have the same order, then A plus B, A minus B, A by B can easily be computed. This one can easily be computed. So, example, if you have A, 1, 2, 3, B, 3, 4, 0, then A plus B is going to be 1 plus 3, 2 plus 4, 3 plus 0, giving us 4, 6, 3. And if A is 1, 0, 2, 3, and B is 1, 2, 3, A plus B cannot be computed. A minus B cannot be computed. Scalar multiplication. You have a matrix A and then multiplied by a number 2. Then you say 2, 1, 0, 2, 3 is equal to 2, 0, 4, 6. So you can just multiply each entry by that scalar. That's also an easy task. Now we look at the matrix multiplication.
Sir, hold on just a bit, the previous screen.
Recording in progress.
Okay, thank you.
Matrix multiplication, we multiply row
Sir, the previous page.
by column. So you multiply row by column. So it means that for two matrices to be, for you to be able to multiply two matrices, you need a matrix. If this guy is n by m, it can only be multiplied by yes, by m. First we put it here. I see. One,
So I'm asking for the
two.
previous slide. I was experiencing poor network.
Okay. And let's see. Papa.
All right, thank you.
No one wants to moderate.
Thank you, sir.
Okay. So if we have, so I'll demonstrate so that you can put the formula here. So if you have 210, papa, papa, papa. Okay. So what is important is the number of columns in the first matrix should be equal to the number of rows in the second matrix. Okay. So the number of columns in matrix A should be equal to the number of rows in matrix B for us to be able to multiply, like this one. 1, -1, 1, 2, 0, 0, 3, -1, 3. We can multiply by 2, 1, 0, giving us 1 by 2, 1 by 2 plus 2 by 1. So 1 by 2, 2 by 1, and you are adding plus 3 by 0. And then come the next one, -1 by 2 plus 0 by 1 plus -1 by 0. Again, 1 by 2 plus 0 by 1 plus 3 by 0. So we'll get the matrix 2 plus 2, 4, -1 by 2, and then 2. So this is a matrix that we'll get. So what is key here is we just came here to pick the formula. Yes.
So,
Hello.
so can you multiply the other way around, like B by A?
Mm-mm.
Is it possible?
Not possible. Matrices are not commutative. Matrix multiplication is not commutative. So because you can find A, B, it does not mean that you can also find B, A. Because for you to multiply A and B, you require that A should have the order n by m. Then you can multiply now by a matrix of order m by anything. As long as the number of columns in the left matrix are equal to the number of rows in the right matrix, you can do the multiplication.
Thank you.
So that in all square matrices one can easily multiply. So after we know how to multiply matrices, now we can move on to the determinant.
So
1 2 by 2 matrix. Any concern? Hello?
it's okay, sir. I'll ask you later.
I'll answer. 2 by 2 matrix. Suppose A is a matrix A, B, C, D. Then the determinant of A, which you can also denote by this, is equal to A multiplied by D minus B multiplied by C. Example, find determinant A and B. If A is equal to determinant A is equal to 2 by 4 minus 3 by negative 1, which is 8 plus 3 is 11. Then we do 3 by 3.
Wait.
Sir, sorry, the previous page.
No, not this one, sir. Okay, thank you.
3 by 3 matrices. I'll post guys. I'll just this. If A is a matrix, yeah, I'll just go straight in an example. If A is a matrix 1, 2, 3, negative 2, 0, 1, 3, 2, negative 1. Find determinant A. So, solution, determinant A is equal to, you go to A and pick any row or any column of your own choice. The only thing you must remember is that the first entry has an invisible plus. So negative plus, negative plus, negative plus, negative plus. Those are invisible signs there. Once you remember that there are such invisible signs, then you can come here and pick any row that you want. So today I'm going to pick the second one. I'm going to pick the second column. I'll pick this column. So when I pick 2, it will be negative 2. And then I cancel this column where that 2 is, and also cancel the row where it is. Then I'll remain with a matrix, negative 2, 1, 3, negative 1. And then I would get the determinant of this matrix and multiply by the entry. So the determinant of this matrix, as I've agreed, is negative 2 by negative 1 minus 1 by 3. This is 2 minus 3, which is negative 1. So we get negative 1. And then I'll come to the second one. The second one is 0, and it has a plus. Now, when there is 0, I don't bother myself to see which matrix has remained, because I'm going to multiply by 0. I move to the next one, minus 2, and then cancel again this guy and the row. So I'll remain with matrix 1, 3, negative 2, 1, and get the determinant of this matrix, which is 1 minus 3 by negative 2, giving us 1 plus 6, which is 7. So I'm multiplying this guy by 7. And so we have 3 minus 14, which is equal to negative 11 as the determinant.
So I've got a question.
Okay.
Is it that you can use any column you want because when finding the determinant?
I can use any column or any row that you want to find the same determinant.
Oh, okay.
Yes. So hello.
Sir, yes, I think, can you kindly explain again?
I explain again. So I'm going to explain.
Yes, you can repeat again.
Excuse me, sir, I'm getting a negative 2. Negative.
You're getting a negative?
12, not 11.
How
I think
come?
there where you put 3, that's supposed to be a 2.
I have put 3.
Yes, negative 2 by negative 1.
Negative 2 by negative 1. Let's go through. The first one is negative 2. Then we cancel, remain with negative 2, 1, 3, 1. Negative 1, yeah. Second one, we cancel 2. We have 1, negative 2, 3, 1. Which entry?
On the determinant A part, you've said negative 2 times negative 1, but then you've written a 3 instead of a 2.
Okay. All right. This is 2. So it's negative 12. Thank you. So it's negative 12. So I explain again. B is a matrix 2, 4, 6, negative 3, negative 1, 0, 4, 1, and negative 2. We want to find the determinant of this matrix. So say determinant B is equal to, we now want to use the third row and see if we get the same solution. So whenever I'm at an entry, the invisible sign is positive. So I have positive 6. And then I'll cut this line and also this line. What I'll remain with, I'll get the determinant. So negative 3 by 1, you get negative 3 minus 4 by negative 1. And then go to 0. Once it's 0, I just put 0 here and cross over to the next guy. The next guy is plus. So I'll have plus negative 1. Oh, I've gone to the other matrix, the old one. I'll have plus negative 2. So I'm here now. Cancel this guy, cancel this one, and then get the determinant of the remaining matrix. So 2 by negative 1, we get negative 2. Minus 4 by negative 3, we get negative 12. So it's plus 12. So that we get 6 multiplied by 4 minus 3, 1. Minus 2 by 10. So we get 6 minus 20, which is equal to negative 14. So we can choose any row or any column, and you still get the determinant of that matrix. Any question? Any question, those who are abroad? No question. All right. This is enough. Matrices multiplication.
Sir,
Hello?
the sign. How do they work?
Which sign?
The positive, negative, positive. Negative, positive, negative.
So you only use them when you're getting the determinant and the cofactor matrix. Only that time.
No.
We move a bit. This is the second last thing that we are doing in matrices.
Sorry, sir. I'm kind of asking for the previous slide. Okay, thank you, sir. I'm done.
So we talk about Cramer's rule. This is a very, very simple rule. It is used to solve systems of equations. An example, then we'll give the formula. Solve for x, y, and z given x plus 2y is equal to 5, y minus 3z is equal to 5, 3x minus z is equal to 4. First thing that you do is you construct a matrix. Let's call it matrix A, where you pick the coefficients of the variables on the left. So have 1 for x. Since there's no x here, it means that its coefficient was 0. And 3. We got y 2, 1, 0. We got z 0, negative 3, negative 1. If you multiply this by x, y, z, we must get the numbers on the right. 5, 5, 4. So under Cramer's rule, you get the determinant of so we're getting the coefficients of x to form the first column, coefficient of y to form the second column, coefficient of z to form the third column. Zero. So you follow y in each equation and you pick the coefficient. If you don't find y in that equation, the coefficient will be 0. So we're calling this one A, and then we can call this one capital X, and we call this one B. So we are saying AX is equal to B. Using Cramer's rule, you get determinant A. Determinant A, you can use the first column, we have 1, and then cancel, get negative 1, and then minus 0, plus 3, cancel, get negative 6, minus 0. So that this becomes negative 1 minus 18, which is negative 19. This is determinant A. Then now you form the matrix that we call AX by, you go to matrix A and replace the X column by B. So where there is the first column there, we'll put 5, 5, 4, and then maintain the other columns for the matrix A. And get the determinant. So what is determinant AX? We go for the first row, we have 5, cancel, cancel, we get negative 1, minus 2, we cancel, cancel, get negative 5, plus 12, and then plus 0, giving us -5 minus 14, which is equal to -19. Then get matrix AY, which is in the matrix A, we remove that column and put the right numbers, and then get the determinant of AY. So we use the first row, we have 1, cancel, get -5 plus 12, and then -5, cancel, we get +9 plus 0. So we have 7 minus 45, which is equal to -8. And then get matrix AZ, which is 1, 0, 3, 2, 1, 0, 5, 5, 4, and get determinant AZ. We use the first column, we have 1, and then 4, and then plus 0, plus 3, we have 10 minus 5, giving us 4 plus 15, which is equal to 19. Therefore, X will be given by determinant AX over determinant A, which is equal to -19 over -19, which is equal to 1. Y will be given by determinant AY over determinant A, which is -38 over -19, which is equal to +2. And Z will be given by determinant AZ over determinant A, which is equal to 19 over -19, which is -1. You can prove if this makes sense in your equations. Then look like, for example, X is 1. And Y, or it does. When X is 1 in the first one, we have 1 plus 2, Y is 2, for sure we'll get 5. When Y is 2 in the second one, Z is -1, for sure we get 5. When X is 1 and Z is -1, we get 4. So you can check in your equations if the equations are satisfied. And we have checked and they are satisfied. And we call this example 1 on Cramer's rule. So when it cuts, you log back. So now we can look at how to obtain inverses of matrices, so that we can also look at how to use inverses to solve the system of equations. That's our next subtopic, inverses of matrices. This is called Cramer's rule, and this example is enough.